Again, welcome to Statistics course. And this is again our lectures for Unit 6, Part 4. In these lectures, we're going to discuss about confidence intervals for variance and also standard deviation. So this means we also have to cover the chi-square and using the chi-square table also. So our main objective in these lectures is covering what the confidence intervals for, again, variance and standard deviation. So our main objective: interpolate the chi-square distribution and also the usage of chi-square distribution table. We're also going to use the chi-square distribution to construct the confidence interval for variance and standard deviation. Again, the main reason why we are using chi-square here, again, because we are dealing with the intervals for, again, variance and standard deviation. So chi-square distribution, we say the point estimate for the variance, again, the variance is sample variance. So the point estimate for population standard deviation is also the sample standard deviation. So this is the estimate population parameters with the sample statistic. So we have the population and the symbol again for variance for population, and also the variance for statistic, which is a sample. Then the standard deviation for population and standard deviation for sample. So as from our previous lectures, we said again, the population characteristics are called parameters and the sample characteristics are called statistic. So here we said we can use the chi-square distribution to construct a confidence interval for the variance and standard deviation. We already learned how to construct a confidence interval using the mean values, population mean. Here again, using variance and standard deviation to construct a confidence interval. So here we say that, okay, if it's a random variable x and it has a normal distribution, then the distribution of chi-square will be n minus 1. S square is our sample variance, and sigma square will be our population variance. So the formula is the sample size minus 1 times the sample variance divided by population variance. That's if the random variable x has a normal distribution. And this will form the chi-square distribution for samples of any size which is less than greater than 1. So the sample size have to be at least greater than 1. Again, one more time here, we are using the chi-square distribution, and the main reason here is, again, to test our variance and standard deviation, or find the confidence interval for the variance and standard deviation. Now, we said that if the x random variable is a normal distribution, then the chi-square can give us n minus 1. Again, lowercase n is the sample size. S square is the sample for the variance, and sigma square again is the population variance, or variance for population. So the properties of chi-square distribution, we say that all chi-square values are always greater than or equal to 0. So which means a chi-square value can never be a negative value. So a chi-square values, we represent the S square as the chi-square values. When we are doing, let me go back, when we are testing, do our testing for the chi-square, this is the formula we use. So S square here basically means chi-square. This is only if the random variable is a normal distribution. Then it will be n minus 1 S square, which is the sample variance, sigma square, which is again the population variance. and always the chi-square distribution for all samples that at least greater than 1. So all chi-square values are greater than or equal to 0. And secondly, the chi-square distribution is a family of curves, each determined by the degrees of freedom. So again, to form a confidence interval for population variance, we use the chi-square distribution with degree of freedom equal to 1 less than the sample size. So again, the degree of freedom will be n minus 1 less than the sample size. That's to form the confidence interval for, again, population variance. We use the chi-square distribution with a degree of freedom n minus 1. Then the third step, the area under each curve of the chi-square distribution equals 1. So the area under each curve of the chi-square distribution equals 1. Now the chi-square distribution are always positively skewed. So we can see the degree of freedom 2, still positive skew. Degree of freedom 5, we can see it's reducing. So the higher the degree of freedom, the lesser the skew goes. So this would be a chi-square distribution. So again, chi-square distribution is not a normal distribution. It's a positive skewed distribution. Then we can also find we talk about the critical values, and when we are doing hypothesis testing, our critical value will be the boundary where either we accept or reject the HO, the null hypothesis. So here also we can find the critical value for chi-square. These are 2 critical values for each level of confidence. So we can see the blue area again, that's our critical boundary. And the value for the chi-square will represent the right tail critical value. Right tail critical value. This is, the value we mean here is that the value from the table, the value from the chi-square table always represent right tail critical value, not the left tail, right. Actually, that's what we have here. Chi-square are the right tail. Now the value of the chi-square, the left L represent the left tail critical value. So now this is the formula. 1 minus C divided by 2 to the left, 1 minus C divided by 2 to the right. Then we have our C area. So the area between the left and right critical value is C. Now, why we divide by 2? Because we have 2 tails. So 1 minus C divided by 2, 1 minus C divided by 2 to the left and to the right. So let's do an example for the critical value. As we saw, to the left is 1 minus C divided by 2, to the right 1 minus C divided by 2. Then the brown area in the middle will be our C value. So now the question is, and that is the boundary line to the left and right is given. So here, for example, we say find the critical values for chi-square right and chi-square left for 90% confidence interval when the sample size is 20. So this is a very good example with the theory that we just went through. So now we are looking for the critical value for both left and right chi-square, and our confidence interval is 90%. The sample size is given to us to be 20. So first we can find the degree of freedom, which will be n minus 1. The sample size is 20 minus 1, that gives us 19. Then second, each area in the table will represent the region under the chi-square curve to the right of the critical values. So we find the area to the right chi-square is 1 minus C over 2. Remember, C is our 90% confidence interval, so that's 0.9. So we get 1 minus 0.9 over 2, which gives us 0.05. Now, area to the right of the chi-square will be 1 plus c over 2, which will give us again 0.95. 1.9 divided by 2 give us 0.95. So total should give us again 100% 1. So that's again the each area in the table represent the region under the chi-square curve to the right of the critical value. So to the right, we have 1 minus c over 2. To the left, 1 plus c over 2. So now we go to our table, our chi-square distribution table. First, we have to look at the degree of freedom was 19. The degree of freedom is 19. So here we go to 19. That's degree of freedom 19. Then we go to 0.05. 0.05. Why? We are doing the x chi-square right tail. Let's go back to the question again. Chi-square right tail, right, r, is 0.05, which is 1 minus c over 2, 0.05. So I know my degree of freedom. I know the 0.05 chi-square to the right. So we get the value, degree of freedom, then 0.05. So the chi-square value here will give me, for 0.05, I'll get 30.144. Then we have a second one for 0.95. We have the left, chi-square left, 1 plus c over 2, 1 plus 0.90 over 2, which gave me 0.95. So we get for the right, and also 0.95 is 10.117. And let's go back. I'm going to repeat this over again. So we start with the question. Again, this is the theory. So this is the question again. Here they say we should find the critical values for right side chi-square, left side chi-square for 90% confidence interval when the sample size is 20. So first thing we're going to find is the degree of freedom. Then after that, we can find the S-square, the chi-square for both right and left. So here for the right, it will be 1 minus c over 2. For the left, it will be 1 plus c over 2. Then after that, we go to our table. We go to the degree of freedom 19. To the right, we have 0.05. So we have to go all the way to 0.05. So our answer is 30.144. Then we go to the left is 0.95. So left was 0.95, 0.95. So that gives us 10.117. So here we say the 90% of the area under curve will lie between 10.117 and 30.114. So this again, the concept of finding, this is 90% confidence interval that our area under the curve will lie between 10.117 and 30.115. So confidence interval for, again, the variance. Here we are using population variance to be n minus 1 s squared to the right side, n minus 1 s squared to the left side, or the chi-square left. So here we say that the variance, population variance, should be less than n minus 1 s squared, which is the sample variance, divided by chi-square left. Should be less, and also should be greater than n minus 1 and the sample variance divided by the chi-square right. So it should be greater to the right and lesser to the left. That is the confidence interval for the population variance. Now, confidence interval for the population standard deviation is just the square root. So square root of everything to the left, everything to the right. Now here we say the probability that the confidence interval contains population variance or population standard deviation is always the C, is C, which is again the confidence. So let's go in step by step how we solve confidence interval for, again, either population variance or population standard deviation. So the first thing we have to do is to verify that our population has a normal distribution. So it have to be normal distribution. Then the second step, we have to identify the sample statistic, that's the sample size, and also the degree of freedom. So degree of freedom will be n-1. Then we find the point estimate for the sample variance, which is each value x minus the mean or square divided by n-1. So we can say this is the exact formula we use in descriptive statistics to find the variance. Here we are finding the sample variance, but to find the variance and the data we are using is a sample, it will be divided by n-1. If it's a population, to divide by n. So this is exact formula for descriptive statistics, finding the sample variance. Sample variance is always subtract each value from the mean and square it, then add all of them. Then you divide by the one less than the sample size. If it's population, you divide by the population size. So that's the first 3 steps. First, we need to verify if the population is a normal distribution. Then we find the degree of freedom when we know the sample size. Then we come and find the variance for the sample. Now we can find the critical value to both the left and the right that correspond to the given level of confidence C. So this is exact steps we did previously. Use table 6. The table 6 in this course textbook is the child distribution table. So I should have written here, use the child distribution table. Again, table 6 is the child distribution table. So it's like the previous work we did. We find the degree of freedom. By here, we were able to find SR, and then, S square R, which is the child square to the right and child square to the left. If you remember, that's the previous example. We were able to find that using 1 minus C divided by 2 and 1 plus C divided by 2 for left. 1 minus C divided by 2 is for the right. But now, if we are doing confidence interval for variance or standard deviation, which is given, we need to find the standard. Here, we're doing standard deviation first, so we need to find the sample standard deviation. Previous one, we found the confidence interval, not for variance or standard deviation. We can go down one more time, then we come back. Reason why I want us to understand the difference, we can see how the question is formulated. Here they say find the critical value for both left and right child square for 90% confidence interval when the sample size. So we're only looking for the critical values. So we have the degree of freedom. To the right, 1 minus C over 2. To the left, 1 plus C over 2. C is our confidence interval value, which is given to us to be 90% or 0.9. So when we get a table, we look for those values. We know the C is 0.05, degree of freedom is 19. For left is 0.95, we find 0.95, and then we find the value. Degree of freedom is the same for both left and right. But in this case, we are doing the confidence interval for variance and also standard deviation. So first thing, we verify if we have a normal distribution, then we find the degree of freedom. Then after that, we find the point estimate for the variance, sample variance, which is the same formula as finding descriptive statistics, finding the sample variance. After that, we use the 2 values here again to get the critical values for child square, the left and the right. That will correspond to the given level of confidence C. And that's what we did in the previous example. In the question, they will give us the confidence either 90%, or it can be 95%, etc. Then use the table C. Again, table 6 here means use the chi-square table. Then after that, we find the left and also the right endpoints. Then we form the confidence interval for the population variance. So this will be our confidence interval. This is again population variance. It should be greater than n-1 sample variance divided by chi-square R value. And it should be less than n-1 times the sample variance divided by chi-square L value. The left, L means the left, chi-square left. Then after that, we find this is for variance. Now we find for the standard deviation. So standard deviation will basically be square root of the variance value. So we square root both sides. And let's do one example, hopefully, and the example may help us more to understand this concept. So here we are going to construct a confidence interval using, again, variance. Previously, we construct a confidence interval using the mean. We remember we have to find the margin of error, which will be, again, the Z1 minus half over 2 times the SE, which is the standard error. Now, that's a different method because that one we find the confidence interval for the mean. So it will be the mean plus or minus the margin of error. The margin of error is standard error Z1 minus half over 2. Here now we are constructing the same confidence interval, but confidence interval for variance or standard deviation. And we have to use the chi-square distribution table. So our question here says you randomly select and weigh 30 samples of an allergy medicine. So we have 30 samples of an allergy medicine, randomly select. Then the sample standard deviation was 1.2 milligrams. Assuming the weights are normally distributed, so the first condition we have met it, they have to be normally distributed. If it's normally distributed, then the question is saying, construct 99% confidence interval for the population variance and also the standard deviation. So we're going to concentrate on population variance. The answer we get, we find a square root to get a standard deviation confidence interval. So the first thing condition we look at the steps is we should see if our data is normally distributed. Yes, based on this question, they say the weights are normally distributed. So we meet that condition already. Second, we find the degree of freedom. The sample size is 30. 30 minus 1 will give us 29. So our degree of freedom is 29. Then the next step, we are going to find to the area to the right and the area to the left. So area to the right of the chi-square is 1 minus C over 2, which was 99%. So it's 1 minus 0.22 over 2, which gives me 0.005. Then we find the area to the right of chi-square left. Sorry, area to the left. The left. So the left always is 1 plus C. We saw this example before. Right is 1 minus C over 2. Left will be 1 plus C over 2. So we get 1.0.992. The total, both of them should give you 1 or 100%. So second one, we get 0.995. So we are good to go now. Now we're going to look for the critical values. Now here we have to look for our table. We did this exact example. Go to the chi-square distribution table and then look at the degree of freedom. I think the degree of freedom was 29. The degree of freedom is 29 because the sample size is 30. So go to the chi-square table as we saw in the previous example in this video. Then you go to degree of freedom 29. Then look for 0.005 is for the right. Then you get a value there. That was 52.336. The same degree of freedom 29. The left side was 0.995. So look at the top for 0.995. 0.995 will be the column. Look at the top column, 0.995. And when you look at the value across, top column 0.995 and the row 29 degree of freedom, you get 13.121. So these two values again we get it from the chi-square distribution table. One more time, let me go back. There was an example how to use the table here. So yeah. So again, this is in this example here, our degree of freedom was 19. So we can only see up to 19. But again, go to the degree of freedom, you see 29. When you get 29, look for 0.995. 0.995 is always the first value. So 29.995 intersection, whatever you get, then 29 and 0.005 will be the last value here. So again, those two values, we get it from the table. This is it again, because we already know chi-square to the right, 0.005, that's the column at the top. Then chi-square left is 0.995 at the top. Degree of freedom will be the row, which is 29, 30 minus 1. So we get these two values. Now we are coming to state our confidence interval for the population variance. So this is the left endpoint, as again we saw the formula, n minus 1, the sample variance divided by, we have this value already, the chi-square to the right. So it will be 30 minus 1. Remember, this is given to us. They say the standard deviation from the question of the standard deviation for the sample was 1.2. I'm going back to the question. The sample standard deviation is 1.2. So this means finding the variance, we just have to square it. So this is the sample standard deviation is given. So what will be the sample variance? We square it. We already find the chi-square to the right, which was 52.336. So we have our first left-hand point. We go to the right-hand point, the same formula, but we divide by chi-square to the left. So 30 minus 1 times 1.20 square over 13.12, and that gave us 3.18. So this means the confidence interval for the population variance will be from 0.80, greater than 0.80 to less than 3.18. And remember, in the question, we are using 99%. So here we can say with 99% confidence, you can say that the population variance is between 0.80 and 3.18 milligrams. Again, the confidence they gave us was 99%, and that's what we use to find the chi-square right and left. You can see the C values is 0.99. So now, if we know the variance, then the standard deviation will be the square root of the values. So we just square root the values. We have this answer 0.89 and 1.78. So here we again 99% confidence that the population standard deviation is between 0.89 to 1.78. So this will be the summary of our lectures on confidence interval for both variance and standard deviation. So in this lecture, we learn how to interpret the chi-square distribution and use the chi-square distribution table. We also use the chi-square distribution to construct the confidence interval for both the variance and also the standard deviation. So the whole concept here is that previous lectures, we find the confidence interval for mean. Looking for confidence interval for mean, it will be the mean plus or minus the margin of error. Margin of error is the standard error times the z, 1 minus alpha over 2. Alpha is our significance level, which will be given always. And in that mean here, we are using the z table or the standard normal table. Now, constructing the confidence interval for variance or standard deviation, we use the chi-square table. So first we have to know the confidence. Then we have to find the chi-square to the left, chi-square to the right. The left is always, again, 1 minus, left is always 1 plus c over 2, and then the other is 1 minus c over 2. We get those two values. Then we also have to surely know the degree of freedom. When we get the degree of freedom, it's normally the sample size minus 1. Then we can go to the chi-square distribution table to get our values. So again, this lecture will be the conclusion of using the chi-square table or distribution to construct a confidence interval for both variance, population variance, and also population standard deviation. Again, wish everybody the best, and thank you.